Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 23rd. Looking at significant wave heights for the North Pacific Ocean, we see a rather calm pattern setting up. A little bit of low pressure here in the central northern Pacific, generating some mild seas, but nothing worthy of swell generation. And honestly, the forecast doesn't look much better. Let's get into the details. We'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We see a pretty healthy jet, actually, consolidated, flowing roughly on about the 38 north latitude line across the Pacific. Winds to 150 knots in a pocket here, and 140 knots here, and generally looking pretty healthy, all said and done. But there is no troughs. That is a dip. We're looking for dips in the jet stream. We really don't see it. The dip in the jet stream helps support a counterclockwise flow aloft and down at the surface. And of course, that's the hallmark of low pressure. Low pressure, of course, generates wind. Wind generates seas. Seas, as they move away from the fetch area, turn into swell. And swell, of course, makes surf. So right now, good jet stream, but no troughs. As we roll this out, we see a bit of a trough trying to organize here off Japan, this general area here. And that's on Tuesday, but then the winds sort of peter out in association with it. Notice it's a ridge, the opposite of a trough. That supports high pressure down at the surface. That's built off California and north of Hawaii by Wednesday. There's a little bit of a trough there on the dateline Wednesday night, but it quickly pinches off, too tight to really support gale formation, and that's gone. The ridge builds off the California coast. Now notice this though, inland, there is a trough. That would be good for low pressure here, but you would have high pressure out here under the ridge. The gradient between the two would do a lot for generating north winds. Yeah, wind swell, but that's not really what we're looking for. We're looking for a longer period swell. That probably isn't going to happen. We'll roll this out. Still, the jet looking reasonably good. Another bit of something trying to sort of be a trough here almost a week out, but probably not. The real issue here is we're moving well into spring, almost approaching summer, and temperature, difference in pressure between temperature to the north, temperature to the south is not that great anymore, and so you just don't get the dynamics going to allow a gale to form. And so even if the jet stream looks great, if you don't have the temperature difference, then you don't get storms, and then you don't get surf. So that's sort of the scenario. Not unexpected given the time of the year. And the interesting part is the jet is still relatively healthy. If this keeps up through the summer, it would bode well for the fall. But we're way too soon to be calling any of that. Pretty soon we're going to start switching this view to the southern hemi, and we'll dig in deeper there. But not this week. So next we look at surface level pressure, surface level winds, and not unexpectedly, low pressure right here over just east of the dateline, south of the Aleutians. And so there is, you can see this difference. You know the jet stream's running right along in here. Sure enough, low pressure to the north, high pressure to the south. A little bit of a gradient between the two. We have a little patch of 30-knot winds here, but as you see, that moves off to the east come Monday and then pretty much dissipates. And that's sort of the tune that's going to be played the rest of the week. Notice, here we go. Here's high pressure off the coast, generating north winds, and another high pressure here approaching the dateline region. A little bit of a low tries to organize off Japan on Thursday. But notice all the winds pointed to the north, 45-knot winds, nothing off to the east or southeast, not a whole lot going on. Here we go, high pressure. Remember, we talked about that gradient between the ridge off the coast and the trough inland, and there you go, 30-knot north winds projected along the California coast. That will drop water temperatures, which have kind of returned to something that's comfortable. It probably set up a lot. This will set up a lot of upwelling and drop temperatures again. Good for marine life, not so good for surfing, and maybe good for producing some local wind swell. But all that fetch is probably going to be pretty close to the coast, and it'll be pretty messy is the expectation. We roll this out. We're into Saturday, Sunday. We're just not seeing anything. Little patch of 35-knot winds off Japan on Sunday. And that quickly evaporates. We're out 180 hours. And most, again, the dynamics are just not here to support gale formation. Let's take a look at the wave models. Here we go. Significant wave heights for the North Pacific Ocean. We see a pretty placid pattern going on. There's that little bit of seas. What is that? peak on Monday, 16 feet. Probably aren't even going to get any wind swell out of that. It'll all decay before it reaches land. We'll just roll through this. We're looking for anything that's in the reds, showing us at least some 20-foot plus seas. We have that here, remember, associated with south winds off of Japan on Thursday, all heading towards the Aleutians of no real interest. We'll just roll this on out. A little bit of fetch off of Canada on Saturday, but for the most part, it's outside of the Great Circle Pass for anywhere but maybe Oregon, and even that is marginal this far out into the future. There we go at 180 hours. So things pretty calm in the North Pacific. We'll just take a quick look at the southern hemi-jet stream. Same sort of deal, only looking for troughs. That is, the wind should curve up to the north, a little bit of a trough like right there. That would get you a clockwise flow. And in the southern hemi, clockwise flow is the sign of low pressure. And we see a bit of a pretty decent trough there on Monday in the central Pacific. And that continues into Wednesday, being fed. There we go. Pretty nice little trough by almost Wednesday night into Thursday, being fed by 140 knot winds. Some support for gale development there. And that pattern just sort of, notice it keeps regenerating as we get into Saturday. Let's see where we go from there. Area under New Zealand, though, ridge sets up by Sunday, probably blocking it off. Again, still possible trough here. Most of that is outside of the California wind, swell window now, about 118 or so west. But earlier in the week, some support there. Let's take a look at the wave models real quick. Here we go. Significant wave heights, South Pacific Ocean. This is the new 3-hour increment model, so it'll take a little bit longer to step through this, but you can see a little bit of a gale is forecast developing on Tuesday. Seas into the 35, 36, so this 37 feet, 21Z on Tuesday, up to 38 feet. Not bad. That and pushing, notice this, pushing a bit off to the northeast. That should set up and in the California swell window, a little bit past Hawaii though. Still should set up some swell if it forms, and that seems reasonable. Another system also forecast on Thursday with 34-foot seas building to 36, 37 feet into Thursday night, and that maybe some energy for Hawaii, but certainly for the U.S. West Coast into Central America and Peru. Not a big system, but lifting northeast, that's good. And then we're into Saturday. That continues even. Small area. I mean, this is not a big system, and remember, we saw that in the upper level model, sort of persistent trough, but now it's starting to move out of the Southern California window on Sunday with 40-foot seas out of the window. Certainly good for Chile and Peru, though. And then we're out of there and things settle down. So looking back in time also, so there is one pretty solid southern hemiswell that was in the water yesterday relative to California. Kind of surprising. Northern California waves were head high, maybe even occasionally a little bit overhead on the bigger sets for a small window when the tide and the wind was right. That swell is still there today and will slowly fade over the next several days. Looking back in time, we got another system a week ago, Sunday, that organized southeast of New Zealand, 30-foot seas, and then sort of tried to reorganize seas up into about the 33-foot range last Monday night. That swell is already pushing to the north. It'll arrive this week. And then yet another system started developing under New Zealand last Thursday, the 20th, 33-foot seas, and build up to about 39 feet, still over a small area, but this was actually unshadowed relative to Tahiti and relative to California, and some energy also up into Hawaii is expected as well. Notice it kind of redeveloped and pushed to the north. We'll show this again. Secondary fetch on Friday. That certainly should add some swell into the mix, probably into next weekend. And then, let's see, I think that's about where we are. That's the end of it. So, swell in the water right now, a second swell behind that, a third swell behind that, and then we looked at the models that suggest yet a fourth swell behind that. So clearly the southern hemisphere is awake and starting to be productive, and clearly the northern hemisphere is well asleep and not doing a whole lot, and that switch happened pretty much over a 1-week period of time. Let's take a look long-term, what's setting up, especially with the Madden-Julian Oscillation, and of course the El Nino Southern Oscillation, or commonly known as El Nino or La Nina. First up, we like to look at winds in the Kelvin wave generation area. What's that all about? Well, we're trying to monitor the status of the Madden-Julian oscillation. So here's the equator, East Pacific here, West Pacific here. These are winds, 5-day average winds from the TAO buoy array, not real time, not per the hour, 5-day average. So it takes a little while sometimes if something changed for this to pick up about 2 days, runs about 2 days behind what's really happening. But it gives you an idea what's going on. Clearly trades in effect the whole way from the east to the West Pacific. We would notice a bit weaker here in the West Pacific Kelvin wave generation area from 170 west, 5 degrees north and south of the equator over to, this is New Guinea here, so right about this area, that box right there. Differences in normal, anomalies. Differences in normal for this time of year, we see basically no differences. This is pretty much a normal, not a La Nina enhanced trade, not an El Nino west wind burst enhanced trade, just pretty much flat normal. And that's about what we'd expect given all the environmental indicators that we've been monitoring over the past weeks. Next, we'll take a look at forecast winds. Again, Kelvin wave generation area between here and this tick and this tick. This is the whole planet on one chart. The blues are easterly anomalies. The yellows and oranges are westerly anomalies. This is back in time. We've had this persistent kind of retrograding east wind pattern that has set up. And here we are now, April 23rd. Little bit of easterly anomalies in half the Kelvin wave generation area there between those two ticks. So a little bit there, but a little bit of westerly anomalies off to the east, a little bit of westerly anomalies off to the west. As we go through the week, those easterly anomalies are forecast to weaken. Westerly anomalies forecast to build, but for the most part, on the east end of the Kelvin wave generation area. We really want to see them right around in here. We're not seeing that. Not that it really matters now, given how we're past the winter season, and it is primarily the active phase of the MJO when you have westerly anomalies in the Kelvin wave generation area. That feeds the jet stream and helps support storm formation in the northern hemisphere in the winter months, but also to a lesser extent, you know, there's a lot more variability. If you get a strong MJO, it sometimes can help in the southern hemisphere as well. Right now, we're seeing basically a neutral pattern. So no assistance, but no degradation or nothing to suppress storm development either. Next, we go to the MJO models, trying to get a sense of what's going on. We look at this. This is the analysis panel, initial panel. It depicts weak, so this is outgoing long wave radiation where there's blue, less reflectivity off the ocean surface, sunlight that is, meaning greater cloud cover, perhaps meaning the active phase of the MJO. The yellows, of course, are more sunlight reflectivity, high pressure, and the inactive phase of the MJO. The statistic model suggests a weak active pattern over the Kelvin wave generation area, again from 170 west to about 135 east, right in that box right there. And the model, as you go down here and see over the next 2 weeks, pretty much active phase fading out, a very weak inactive phase projected per this model. But per the dynamic model, the GEFS model, it suggests the active phase, if anything, building a bit and holding while the inactive phase bottles up in the Indian Ocean, trying to make eastward headway, but not making it even 2 weeks out. Next, we take a look at phase diagram charts. Assume you're looking down on the north pole of our planet. The MJO travels from west to east from the Indian Ocean over the maritime continent, through the Pacific, under the U.S., across the Atlantic, over top of Africa, and back to the Indian Ocean. The heavy dot right there, that's where the active phase of the MJO is. If it's inside this circle, it's considered to be extremely weak. So somewhere in the western Pacific, the forecast, follow the green line here, pretty much says the active phase is supposed to stay stationary and weak per the ECMF model. The GEFS model says it's supposed to strengthen a little bit, just like what we saw in the previous charts, over in somewhere in the East Pacific, and then weaken 2 weeks out. The upper level model, this shows propensity for where precipitation is. Where the greens are is where heaviest precipitation is. It runs about 2 weeks ahead of what happens down at the surface, but it suggests some sort of weak active phase here in the West Pacific. Traveling, you can just see the trend over time every 5 days. This making its way into the East Pacific on the 13th of May, followed by the inactive phase after that, pushing into the West Pacific, 3rd of May or so. So really 2 weeks later than that, it's probably about the 15th of May, working its way across the Pacific into the, roughly 28th of May, and then another weak active phase behind that. So in all, the models appear to correlate pretty well. But it is the CFS model that we have the most faith in because historically it is proven to do the best. It's really geared for long-term use. The GFS model is more like a 1 week kind of model. Does a pretty good job at that, but not so good long-term. This model does, if you're looking on periods of weeks and months out, it does better. Anyway, so the chart suggests the Kelvin wave generation area is roughly right in this area. Okay, and you can see this persistent pattern. This is going back in time here. You can see blues, which are easterly anomalies. Here we are right now, suggesting we're right on the cusp of a change. And starting any day now, westerly anomalies, you can see it, our forecast develop. And from here on out, westerly anomalies are the name of the game. Let's take a look why. Well, we can see for sure, here is the active phase of the MJO, just pushing. Now, we're past the peak of the active phase of the MJO over the Kelvin wave generation area, and so that would drive westerly anomalies. That makes sense. But what doesn't make sense is you look at here, the dotted contours are the inactive phase of the MJO. One would expect westerly anomalies to start dying out. But no, they're not supposed to die. If anything, they're weakening a little bit here, but then they're supposed to build back strongly as the next active phase of the MJO sets up sometime in June. So our current active phase fades out, let's say the 3rd or 4th of May, and then we go into this prolonged inactive phase followed by another active phase. But what really is driving this, we'll just turn the MJO off. We'll look at the low pass filter. Here's what's really going on. So this dotted contour is La Nina. Okay, it is steadily been forecast to die by anywhere from May 5th to May 8th, that sort of time frame. The model is still holding that, and notice here's where this is the area that's in the Indian Ocean right now. This is typical La Nina. This is the area where convection, westerly anomalies, whatever you want to call it, most energy is associated. Notice it's supposed to transition over the Kelvin wave generation area on, call it May 28th. And that's about what the model has said. We've been watching this for the past couple of weeks, anywhere from May 25th, May 28th, somewhere in there. So that is still the case. And what this essentially means is some sort of an El Nino-like pattern is supposed to set up over the Kelvin wave generation area. That we get our westerly anomalies. The westerly anomalies start feeding the jet stream, both in the north and southern hemisphere, and theoretically then would help support storm formation. So we got to go through this transition, but we're only a month or so away from that happening. Certainly even just the death of this La Nina pattern would be good enough to get us neutral, but to get into an El Nino-like state would be more than one could ask for. So this looks still quite favorable. So we'll move on now. We will not discuss the MJO anymore because we have a pretty good handle on it. It looks like we're in active phase right now, forecast to fade out, but an El Nino-like pattern theoretically could be coming. What's even more interesting is heat buildup in the ocean. So East Pacific here, West Pacific here. We're looking down the at the anchor lines on buoys strung across the equatorial Pacific. The X's are sensors on those lines. They help tell us where heat is in the ocean. As usual, all the warmth is here. Well, let's see. This is the 28 degree isotherm line, 28 degrees Celsius. All the warmth in the West Pacific. But what we've been watching, this guy consistently had been locked like right in here. And then about a week ago, all of a sudden, it made this big jump off to the east. And look over here, even now, this suggests that warm water is starting to move off to the east. That would suggest that either trades are dying or something's going on. Typically, if you have strong trades here, warm water stays bottled up here. When the trades slacken, boom, warm water starts moving east. This is a very good sign. Now, also, here's anomalies, differences from normal for this time of year. You see warm water, yes, it's moving off. There isn't piles of really warm water. These, 2 degrees over a small area, that's nothing. It's not like there's a giant reservoir of heat here in the West Pacific. So even if we did get westerly anomalies, you wouldn't get much of a Kelvin wave or any kind of heat, and not a lot of fuel for any sort of a strong El Nino. But nonetheless, the path appears to be open. We had suggested, we were looking a couple of days ago thinking maybe that's not the case, mainly associated with this cool pool right here. But this was minus 2 degrees. But you know what? It's getting weaker, at least per this view. And we're thinking if anything else, this is maybe just that there was a Kelvin wave that preceded this, and this is the upwelling phase of the Kelvin wave cycle. And maybe this will fade on out and we'll be back in business here. And the other view here, basically shows the same thing. It shows this kind of cool pool as of April 18th, blocking the normal Kelvin wave flow. Well, not normal. Kelvin waves aren't normal. They typically only occur when you have westerly anomalies. But there is thought that we have had one, and maybe another might be trying to organize. We got to get this guy out of the way first. Another view, upper ocean heat anomalies, the upper 300 meters of the ocean surface back May 2016, La Nina, cool water, that's what the blue is, cooler than normal water. But that pretty much faded out as we got into December of last year. Then we got into this building warm regime, and here is what we thought, we'll go down here, there you go. This might have been what we would call a Kelvin wave. It was kind of weak, not fully supported. There was also westerly anomalies going on off of South America that shut down upwelling there, and that helped contribute to the warm water buildup. So not all this was associated with a Kelvin wave. And then here's that supposed, maybe, if you want to call it, upwelling phase of the Kelvin wave cycle. We would expect to see, you can sort of get a hint that maybe that is moving off to the east. We'll see. It'll take another week or two. We'll see if we start seeing this warm water here start moving off to the east a little bit more. That would help confirm what we think is going on. Anyway, all data at this point is in pretty good agreement. All the different views of the data suggest the same thing. Let's take a look at surface water temperature anomalies. Now, waters here off, this is Peru, Chile, Ecuador. Waters were really cooking warm a couple of weeks ago. They have moderated somewhat. Still, pockets of pretty warm water in the, we'll call it 2 degree range, maybe a little bit more in pockets. A little bit of cooling right in here. But notice, generalized warm water the whole way out to 160 west now. Little pockets of cool, but nothing. The other thing we were noticing there, the upwelling along the coast of Peru was much stronger a week ago. It has significantly dampened now, and generally, even up in the northern hemisphere, warm water in effect. The trend for the past 7 days, I guess you could say there's a couple of pixels of warming along here, but nothing really significant. There was a strong pattern this past week of cooling right here along the Galapagos, Ecuador, in this area. That has finally appeared to dissipate. Warming north and south of the equator, a little bit of cooling here right around south of Hawaii, but nothing major. And generally a warming trend. Also notice the warming trend off California, that it was because trade settled down, and actually water temperatures were up 55 and a half off of San Francisco this past weekend. But we looked at the models. You know what's coming. Nuking north winds, those temperatures will drop precipitously. Also down into California, the same thing, and that will dissipate. But the warming trend should hold from Hawaii. Notice this all out here. Same deal. And then here is the large backed off picture. You can see, of course, warming along South America, across the date line, out. Now notice this is the last little bit of La Nina. We basically are writing it off as of here and saying there is no more La Nina at depth in the ocean or even at the ocean surface anymore. This is pretty much normal noise. This warming over here is anomalously warm, but we are still in the spring unpredictability barrier that runs from 1st of March out into end of May. So you can get warming over here, and it can just as easily dissipate. A lot of noise in this region. This warmth has to make it over into the Nino 3.4 region. This is considered Nino 1.2 here. Nino 3.4 is from 120 west out to 170 west, 5 degrees north and south of the equator. And you can see it's kind of, there's warming to the south, but there's a little bit of cooling to the north. I mean, it's not remarkably warm. It's just lukewarm at best, if you want to call it that. Other thing to notice here, warming, this trend off of the U.S. West Coast, warming here, cooling here. I want to show you something. I want to show you these pictures here, 2 phases of the Pacific decadal oscillation. We've talked about this in the past. This is a 30-year, 15 to 30-year trend. One favors the positive phase, we call it the warm phase, tends to favor the formation of El Nino and certainly favors storm formation. The negative phase is like a long-running La Nina. It doesn't favor storm formation, actually kind of actively suppresses it. Now notice this pattern. Cool water here, warm water to the south, working its way up along the U.S. West Coast. Notice this pattern here. Cool water here, warm water working its way up along the U.S. West Coast. Not super clear, not necessarily time correlated or anything, but we've seen this sort of persistent pattern, and there's other data that suggests that the Pacific decadal oscillation is moving towards the warm phase. This is what we're monitoring, looking for signs of it. We'll get a little bit more into that in a second. Meanwhile, we continue looking for signs of either El Nino, La Nina, or the active phase of the MJO. Really, we're looking to verify that La Nina is dead in the atmosphere. One way to do that, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. If the index is negative, notice it was very negative here, mid-month, minus 30s, and today, minus 3.46. This was actually attributable to low pressure north of Tahiti, a tropical low. Okay, the 30-day running average gives you more. We use that for monitoring the MJO. If it's negative, then we suspect we're moving towards the active phase of the MJO. You can see it's at minus 5.33. So maybe, perhaps, the active phase is trying to get a foothold. And then long-term, the 90-day running average, if it's well negative, that suggests El Nino, or if it's positive, La Nina. Right now, minus 1.29. That's pretty much neutral, saying just a dead neutral pattern. We want to see this get down to about minus 15, then we're in business. Then the ESPI index, same sort of thing. Instead of measuring pressure, it's actual rainfall difference between Australia and north of Tahiti. Current index minus 1.06, suggesting that there is less precipitation in this area than there normally would be. Negative numbers you'd see here. A little bit drier, and that's kind of also the equivalent of the Nino 3.4 region, suggesting cooler water there or something going on in the atmosphere to suppress precipitation. So this suggests that La Nina is still present in the atmosphere, and it probably is. It makes sense, but it should be washing out very soon, just given all the other signs that we've seen. I can't believe it's still at a minus 1.06, but that is expected to change shortly. Looking at PDO numbers, this is from the Washington EDU site. They do it a little bit different than NOAA does, but you still get a general idea. We thought we turned to the active, the warm phase of the PDO, roughly, we'll say March of 2014, and we've had nothing but positive numbers. Of course, all this was enhanced by a super El Nino, but now, even to this day, 0.74. That's as of March. The new numbers should be coming out. Let's see. We're still working our way into April. Anyway, 0.74. And NOAA is saying it just 0.06 and just basically neutral the past 3 months. A little bit of negative there in September, October, but prior to that, all positive. And you sort of go back in time. You see back in 2013 where it was distinctly negative and had been for years. So we're in a bubble at least since 2014, the early part of 2014. Here we go, starting right about there, the March. And you can see down here, it's been pretty positive ever since. Little bit, even through La Nina. That's the interesting part. Even through La Nina, we've managed to eke out mostly positive numbers. The question is, what's going to happen over the next 2 years? If we can get into about a 5-year run of mostly positive numbers, that would suggest that we have, in fact, made the turn to the warm phase of the PDO. And here you go. You can look here. The most recent cold or cool phase of the PDO started right here in 98. Majority of negative values. And then here's where we think things switched over, March of 2014. Now, we'll see. That's a very small sample window to know. And notice this cool phase only lasted for, what was that, about 15 years? Normally they run longer than that. There's a longer running warm phase. So we'll see, but that's a little bit of data that we have right now. That's why we say another 2 years it'll take to really know where we're at. So to wrap things up, Northern Hemisphere appears to be going to sleep. High pressure building in, wind swell upwelling, the name of the game. All eyes on the Southern Hemisphere. One swell in the water hitting, 2 more behind that, and a third forecast on the charts. So get your summer game in gear. Long term, looks like the La Nina phase is pretty much over. We're neutral. Other than the SPI index, otherwise everything suggests we're pretty much neutral, and all the models are suggesting a trend towards some sort of a weak El Nino starting about a month or so, let's say 6 weeks out. So something to look forward to this summer. We got to get through the spring unpredictability barrier, but let's say by June we should know where we're at, and then we'll have a better sense on what's going to happen this fall and winter. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.